Hi ladies, good morning. So separate video here then on the solutions to the homework. The first video I posted there was on the two questions that we did on Friday in the live for anyone that missed it. So this is for everyone now, the solutions to the homework. And part A looked not like that. Sorry. Oh, that was the first one I told you to do though, sorry. Oh, I think it was part C of the question, but it's the one that I talked through briefly at the end of the live on Friday and told you to start with that one. So it looked like this. Anything squared is that by itself. So 1 plus the square root of 7 by 1 plus the square root of 7. Okay, so again, how do we work with these brackets? First term by all of the second bracket, second term by all of the second bracket. Let's just be really explicit about what we're doing. We're multiplying that 1 by all of that bracket first. So 1 by all of the second bracket, and then this number, the second term in that first bracket by all of the second bracket. Okay, so we've this by this, this by this, that by that, that by that. We don't normally write that line out. I normally just from here I go 1 by 1, what's the answer? 1 by root 7, what's the answer? Whereas here I'm just going to show really explicitly that that's what I'm doing. The 1 by all of this first, and then this number, this number, the root 7 by all of this fraction. All of this fraction? All of this, what is this called? Bracket. Okay, so 1 by 1 is 1. 1 by root 7, 1 by x would be 1x. 1 by root 7 is 1 root 7. Again, treat those thirds like x's when you're multiplying these brackets out. Plus, root 7 by 1, x by 1 would be 1x. So root 7 by 1 would be 1 root 7. And, now this is an interesting one. We didn't come across a question like this on Friday where we had a third multiplying its match. Root 7 here by root 7. So, root 7 by root 7. Treating these thirds like x's or variables, like we were on Friday, is that an x and that a y? So was it like x by y would be xy, which means root 7 by root 7 is root 7 root 7? Yeah? Grand. And then I'm just going to play it over here with this for a second. Root 7 by root 7 becomes root 7 by 7. Law 1 tells me the square root of a number by the square root of a number is the same as the square root of the two numbers multiplied together, which is the square root of 49, which is 7. Great. But was there another way to do that to save me all of this, given that the two numbers were the same? Root 7 by root 7. If you were multiplying an x by an x, would you write down xx? It's not wrong to say that x by x becomes xx because there's invisible brackets there, so you're still multiplying two x's. But what do we actually write down when you multiply x by x? We write down x squared. Unlike if it's an x by a different letter, we write that as xy. But if it's x by x, that becomes x squared. It's a nicer way of writing x by x because you have two of them. So x to the power of 2, instead of writing the x's separate. Now you've got two of the same things, just put a wee 2 up there. So, root 7 by root 7, x by x is x squared. So root 7 by root 7 is actually the same as root 7 squared. What happens when you square 7? You get 49, which becomes 7 anyway. Isn't squared and square root the inverse operations of each other? Isn't one the opposite of the other? For example, if you have x squared equals 49, don't we throw the little 2 over the equal sign and it turns into a square root of 49 and then we'd have x equals 7. Squared and square root are inverse operations of one another, which means just like if we had 6 and we were asked to x, and we were asked to add 6 to it and then take 6 away. Sure, we're just going to end up back at x. So similarly, if you're given a number and asked to find the square root of it and then square it, you're being asked to do something which is completely undone and reversed when you do this, because one is the opposite of the other. So to square any number will give you some perfect square number depending on what that number is. So if it's 2 squared, you get a 4. If it's 3 squared, you get 9. If it's 4 squared, you get 16. But then when you go and find the square root of them numbers, which that sign tells us to do, you get back to the actual number that was in there. So you're doing something to undo it again. by finding the square root. Undo it perfectly and get back to where you started. Okay, so just like the root 7 by root 7 turning into root 7 squared, we can just do this. That cancels that. They're the same thing. I don't need to square 7 and get 49, because then I know the square root of 49 is going to get me back to 7. So let's not bother squaring or finding the square root of anything, because those two operations are the inverse of one another. They cancel each other out and we'd be left with 7. Okay, if you want to pause me here and take anything I've got scribbled there down, do, because I'm going to rub out this bit, not to cause confusion what I'm going to do next. So just pause me there, please, if you need to. Oh, sorry. Okay. Yeah, let's get rid of all of that. So root 7 by root 7 is root 7 squared. Bang, bang. Straight away, I've now got a constant of 7 as the answer to that. Instead of what you probably had, which was root 7, and then you would have gotten the next line that, and then you would have got, sorry, in the next line you might have had the square root of 7 by 7, or maybe you jumped straight to the square root of 49, and then you got 7. So rather than doing all of that, you can just at the beginning acknowledge that if they're both the same, square root of 7 by the square root of 7 becomes the square root of 7 squared, cancel, cancel, and you're left with just 7. And then good luck to all this work. Okay, so let's back to here. 1 plus 1 root 7 plus 1 root 7 plus 7. There's a 1 and there's a 7. 1 and 7 is 8. And I've damped up both of them. Now I have a 1 root 7 and a 1 root 7. Can I add them? Don't dare add them unless you're happy they're like terms. What makes them like terms is if they're the same letter. Are they the same letter? Well, let's pretend that's an x. Would that be an x too? Yes, because they're identical. So 1 root 7 is like 1x, and 1 root 7 is like another 1x. So 1x and 1x would be 2x, and therefore 1 root 7 and 2 root 7 is, 1 root 7 and 1 root 7 is 2 root 7s. And I can leave it like that, or I could flip it and put the third out the front and the constant at the end. It doesn't really matter, but I guess it is nice to do it in that way. Okay. Pause me there, girls. I need to take that down, and I'm going to go jump on into 7 minutes. I'm taking far too long as it is. This video is going to be so long. No, I'm going to go quick. I spent the time there explaining that root 7 by root 7 one, so that I won't need to go off on a tangent in the next ones when that occurs. So let's hope I can make this short and sweet. Root 5 by 1 minus root 5. Okay, root 5. Sorry, my battery's low. I need to actually speed up here because I'm not near a charger and I will cry if it cuts me off. So root 5 by 1 minus root 5. Root 5 by this, root 5 by that. Root 5 by 1 is like x by 1. It would be 1x. So root 5 by 1 is 1 root 5. Root 5 by root 5. Now, careful, there's a minus sign in the middle. So a plus sign by a minus sign is going to turn into a minus. Root 5 by root 5 is root 5 squared. Or you can write root 5 by root 5, which ultimately becomes the square root of 25, which simplifies to 5. You will get the same answer that I'm going to get. I'm just going to get there quicker by doing that. Okay, I'm not going to talk anymore about that. We did it a second ago. So your options there to go root 5 by root 5 is perfect. That's just a little bit quicker. So we've got 1 root 5 minus 5. Can I go any further? No. Could I write this as root 5 minus 5 and drop the 1? Yes. Bingo. Okay. Quickly then, let me go on to B. Is it long? No. So B looked like this. Root 2 minus 1 by root 2. I don't like that out there at the back. Let's take it out the front. Nothing against it. If you can do it like that, do it. I'm just going to bring it out to the front for anyone that did to make it a little bit easier. But of course, it's the same thing. And we really should be able to deal with multiplying in from the back anyway. It would just be the same thing. Root 2 by root 2, root 2 squared. Root 2 by minus 1 plus by a minus, minus root 2 by 1, x by 1, 1x. So root 2 by 1, 1 root 2. They cancel. We're left with 2 minus 2 minus what? 2 minus 1 root 2. I could drop the 1 and just leave it as root 2, because that's like a 1x. So could I just write that as x? Sure. Okay. Thirds kind of out the front is a good idea. Really careful here. Sorry, I'm just going to bring that up a bit. I'm now running out of space here, so I can write like that instead. Flipping them so the thirds at the front. You must bring its sign with it, so it becomes this. Minus root 2 and plus 2 at the back. Do we like minus signs at the front of anything? Is that good practice? No. So no to that. Don't take the third out the front if it means bringing a minus sign with it and having a big minus, a big ugly minus sign at the front of your expression. We don't do that. So no to that, leaving it as it is with the third at the back, because the minus sign is the third. Okay, lovely. Sorry, pause there if you need to with that one. If you have any questions on any of these cards, please drop me a message and just say on part C, what was the story with the -2 or whatever. So please don't refrain from asking me questions. I want to hear them just like I would if we were in class. D looked like 5 plus root 2 squared. Anything squared is that thing by itself. So 7 squared is 7 by 7. 5 plus root 2 squared is just 5 plus root 2 by 5 plus root 2. Anyone that wasn't here on Friday actually wouldn't have heard that. So again, this is for anyone that wasn't there on Friday. Definitely the final thing that you missed would have been that idea of seeing something like this with a little squared up there. And just like 600 squared, meaning 600 by 600, 5 plus root 2 squared means 5 plus root 2 by itself that many times, twice. By itself that many times, which is twice. Okay, that by that, that by that. 5 by 5, 25. 5 by root 2, 5 by x would be 5x, so 5 by root 2 is 5 root 2. So whenever you see a third, treat it like an x. Root 2 by 5. So notice this time I'm leaving out that line where I did in the last one, where I was really explicit about the 5 multiplying this bracket first and then the root 2 multiplying that one. Now I'm just doing it like this because I'm getting a bit more confident now, and hopefully you will too. But this is only your second one, I think, of these particular ones, so I kind of skipped that step there by accident because I normally would. But if you need to add that middle line that shows you multiplied 5 by this bracket and then root 2 by that one before you subsequently do it, that's perfect. And do that as well until you get more proficient with these. Where am I? Root 2 by 5. X by 5 would be 5x, so root 2 by 5 is not 5x. Root 2 by 5 is 5 root 2. Root 2 by root 2 is root 2 squared because it's the same number. Root 2 by root 2 squared. If you wrote root 2 by root 2 and subsequently wrote root 4 and root 2, or root 4 and then 2, you get exactly what I'm getting very early on, which is just a 2. You're ending up with a 2 anyway, so that's fine. I hope I've made that clear at this stage, what you can do with that and what the alternative is and how that's okay. 25, 5 root 2, 5 root 2. That's like a 5x and a 5x. Can you add them? Of course you can. What would you get? 10x. So 5 root 2 and 5 root 2 is 5x and 5x is 10x. So 5 root 2 and 5 root 2, 10 root 2. So you get 25 and 10 root 2. I don't know what this is. 25 and 10 root 2 and 2. The root 2 and the 2 that cancel to give me just 2. Any like terms, do not stop until you've all the like terms added. Yes, I've got 2 constants there. And then I've got this thing simplified as much as it can go. Now what? Good like that? Yeah. Flip them around if you want. Bringing this out, we would get 10 root 2 and 27. You would get absolutely no marks for stopping there. If you want, you can bring the third out the front, but you don't need to. That's perfect. Okay. Pause me there if you need to take any of that down. And then we're going to jump on to D, and then E was the last one. E. So it looks like 1 and root 3 by 2 minus root 3. This by this, this by this, this by this, this by this. 1 by 2 is 2. 1 by minus root 3. Hold on. plus by a minus first would be a minus. 1 by root 3 is 1 by x, which is 1x. So 1 by root 3 is just 1 root 3. And I could put that 1 there, I could leave it out. I'm going to put it in and just be explicit about it for the moment. Root 3 by 2. Root 3 by 2 is like a x by 2, which is 2x, and therefore 2 root 3 plus 2 root 3. And then we have a root 3 by a minus root 3. So break it up and do the signs first. Plus by minus is a minus. Root 3 by root 3 is root 3 squared, or that is perfect. And ultimately that, and then that, and then that. I get 3 anyway by just doing that. Okay? I'm going to work this out now, so pause me here if you need to. Two minus 3, like terms there. 2 take away 3, take the sign of the bigger number and subtract the numbers. You get minus 1. And then these are like terms as well, because we've a minus 1x. So it's like a minus 1x because the root or the third is like an x. And then this one is like 2x. Because we've got minus 1 root 3, so that's like a minus 1x, and a plus 1 root 3, which is like a plus 2x. So we can put them two together, and therefore we can put these two together. So minus 1 root 3 and 2 root 3. Sign of the bigger number plus, take the numbers in front of the x away. We don't change the x, we don't change the root 3. We just take the 1 and the 2 from each other and we get 1, and the root 3 stays as it is. Just like up here, if we had minus 1x and 2x, we would get plus 1x. Minus 1 root 3 and plus 2 root 3 will give me 1 root 3. I wonder if you put that into the calculator, actually, do you get this? Does it help you add surds without turning them into decimals? Maybe just check that, or maybe you have already. This doesn't look good out the front, so let's flip and let's drop that 1, because 1 root 3 is like 1x, and 1x is the same as just x. So let's leave it as root 3, and if the plus sign comes with it, and the minus sign goes with the minus 1. And that is our answer. Happy? Okay, girls, 17 minutes. I didn't do too bad, did I? So this is the first 17 minutes of our class. The next few minutes, going to be watching the next video with the questions I'm going to get you to do today, along with a little bit of new work, which brings us to the end of this chapter, actually. And then you're going to do the questions that I'm going to give you. Okay, thank you.